Assalamualaikum warahmatullahi wabarakatuh dan salam sejahtera. Okay, so we continue our lesson with this one. Okay, so theorem yang lepas tu. Okay, so geometric multiplicity and algebraic multiplicity. Okay, so what is algebraic multiplicity? So this one related to how many times the eigenvalues repeat. Okay, so for example lambda equal to 1, 1, 3. Okay, so for lambda equal to 1, algebraic multiplicity is equal to 2. So dia berulang 2 kali. So for lambda equal to 3, algebraic multiplicity equal to 1. So dia berulang sekali. So for the geometric multiplicity, so this one related to the number of bases for the eigenspace. Okay, so kita tengok example here. So example, so determine whether the matrix A equal to 1 to this one is diagonalizable or not. Okay, so solution, first find the eigenvalues. So we have this matrix, determinant of this matrix equal to 0. So negative 1, 1 plus 1. So this one using cofactor expansion along the first column. Okay, so negative 1, 1 plus 1, because row 1 column 1, then 1 minus lambda times by determinant of, okay, so close this one, 1 minus lambda, 0, 2 and 3 minus lambda, and for the next 0 and 0 tak payah nak kira sebab dia kosong-kosong. Okay, so negative 1 power of 2 positive, so we have 1 minus lambda times by determinant of this one, 1 minus lambda times by 3 minus lambda minus by 2 times 0, which is 0, equal to 0. So we have 1 minus lambda and 1 minus lambda and 3 minus lambda equal to 0. Okay, so from here we have 1 minus lambda equal to 0, so lambda equal to 1, and 1 minus lambda equal to 0, lambda equal to 1, and 3 minus lambda equal to 0, so lambda equal to 3. So eigenvalues, lambda equal to 1, 1 and 3. Okay, tersama pula dengan tadi saya conteng kat atas tu. Okay, so next find the eigenvectors. Okay, so find the eigenvectors in order to find the geometric multiplicity. So algebraic multiplicity, we have this one. For this one, algebraic multiplicity is 2. For this one, geometric multiplicity is 1. Okay, so next find the geometric multiplicity. So to find the geometric multiplicity, so we need to find the eigenvectors. Okay, so using this one, for lambda equal to 1, so we have A minus lambda is 1, so 1 times identity, so A minus identity times by eigenvector V equal to 0 vector. Okay, so we have this matrix. Okay, so take transform it. Okay, so nanti kalau dah masukkan matrix dia transform into augmented matrix, then we have this matrix. Okay, so next we need to convert into row echelon form. So first we need to make it this one as become leading 1 by multiplying with 1 over 2. And since here is leading 1, so the below of the leading 1 must be 0. So here 0 and here must be 0. So saya buat serentak sebab saya nampak 2 tolak 2 boleh jadi kosong. So nanti saya tak payahlah nak buat kat sini row 3 tolak 2, row 1 ke semua. Okay, so saya terus tolak dia 2 tolak 2. So therefore I use row 3 minus row 1 and put back at row number 3. Ni saya salah. Okay, so row 3. Okay, so after apply this formula, so I have this matrix. Okay, and then so this one for the V1, V2 and V3. Okay, so yang ni tak payah nak jadikan kosong lah sebab bawah dia ni tak ada leading 1. So leading 1 only here. So for the second row, third row, there is no leading 1. So therefore the leading 1 here is for V2. So V1 and V3 are free variable. Okay, so from row 1. So from row 1, so we have 1 V2 plus 1 V3. So V2 plus V3 equal to 0. Okay, so V2 plus V3 equal to 0. And this one implies that V2 equal to negative V3. Okay, and then for the free variable, which is v1 and v3, so we let v1 equal to t and v3 equal to r. Since from this one v2 equal to negative v3, so we have v2 equal to negative r. So therefore the eigenvector is v1 equal to eigenvector v, it is equal to v1, which is t, v2 negative r, and v3 is equal to r, where r and t element in real number, and r cannot equal to 0 and t also cannot equal to 0. Or you can write down the eigenvector as this one, seperti ini. Okay, so the eigenvector v, it is equal to t. Okay, so t here 1t, so 1, and here there is no t, here also there is no t, so 0, 0. Then plus r, so r, for the first one there is no r, so 0. Kenapa q ni? Kita conteng kot. Okay, so here 0, then negative 1. Okay, so second negative r, so negative 1, and then r, which is 1. So r t element in real number, and r cannot equal to 0 and t cannot equal to 0. Okay, so here the basis for the eigenspace is 1, 0, 0 and 0, 1, 0, negative 1, 1. Okay, so there are two bases. So therefore the geometric multiplicity is equal to 2. Okay, so and from the above the algebraic multiplicity also equal to 2. Okay, so they sama, geometric multiplicity equal to 2, and this one also equal to algebraic multiplicity for lambda equal to 1. Okay, so therefore for lambda equal to 1, condition dia dah betul lah. Okay, so for lambda equal to 3, so this one just now lambda equal to 3, algebraic multiplicity is equal to 1. Okay, so find the eigenvector. Okay, so using this one, a minus 3i times eigenvector v is equal to 0 vector. Okay, so transform into augmented matrix. So we have this kind of matrix, and then we have this form. Okay, so make it this one become leading one, and the below one already 0. So next we make it this one also become leading 1. So buat serentak pun tak apa, sebab ni bawah dia kosong, bawah dia dah kosong-kosong, so boleh buat serentak. Okay, so by multiplying with negative 1 over 2, so we have this matrix, and then here already leading 1, so make it this one become 0. So sebelah sini dah tak ada leading 1, here also already 0, so sini dah tak payah nak usia apa-apa lah, sebab leading 1 dah tak ada lah. Okay, so memang kita tak boleh nak buat leading 1 lah. So ni nak buat turun pun tak boleh lah, sebab sini dah ada leading 1. So bila dah ada leading 1 ni, sini tak boleh nak gerak ke mana-mana lah. So therefore for the third row there is no leading 1. So since the leading 1 is only on the second row and first row, so make it this one become 0, and this one also become 0. Okay, so by using suitable formula, so we have this matrix. Okay, so after that, okay, so this one for the v1, v2 and v3. Okay, so the leading one only for v1 and v2, so therefore v3 is free variable. Okay, so from the first row, so we have 1 v1 minus 1 v3 is equal to 0, and implies this one v1 equal to v3. And from the second row we have 1 v2 which is equal to 0. Okay, so for the free variable, so we let v3 equal to s. Okay, so and this one implies that v1 also equal to s. So we have the eigenvector which is equal to v1 s, v2 0, v3 also s, such that s element in real number with s cannot equal to 0. Okay, and then you also can write down this v as this eigenvector as this one, so s 1 0 1, such that s element in real number and s cannot equal to 0. Okay, okay, after that so this one will become the basis for the eigenspace for lambda equal to 3. So number of bases only 1. Therefore the geometric multiplicity equal to 1. So which is also equal to algebraic multiplicity for lambda equal to 3. So untuk lambda equal to 3, dia punya geometric multiplicity is equal to algebraic multiplicity, which is equal to 1. So therefore A is diagonalizable. Okay, so another example. So determine whether the matrix A is diagonalizable or not. So first find the eigenvalues. Okay, using A minus lambda I equal to 0. So we have this form. So determinant equal to 0. Okay, so I'm using cofactor expansion along the first row. So negative 1 power of 1 plus 1, 2 minus lambda, determinant of negative 1 minus lambda, 2, 0, negative 1 minus lambda. The next one 0 and 0, so tak payah nak kira. Okay, so then we have this equation. So from this equation we have 2 minus lambda equal to 0. So lambda equal to 2. And negative 1 minus lambda equal to 0. So lambda equal to negative 1. And negative 1 minus lambda equal to 0. So lambda equal to negative 1. Okay, so from this one, so we have eigenvalues. Lambda equal to negative 1, and 2. Okay, so biasa kita check yang repeat ni dulu. Okay, so untuk yang repeat, so for lambda equal to negative 1, so A plus I, eigenvector V equal to 0 vector. So find the eigenvectors. Okay, so apa jadi tambah? Sebab ni lah. So tolak lambda I. So lambda is negative 1. So negative 1 become positive 1. So positive I lah. Okay, so we have 2 plus 1, 0, 0, 1, negative 1 plus 1, 2. Okay, so equal to this one. And then calculate. So we have 3. Okay, so equal to this one. And then reduce into row echelon form. So make it this one become leading one. Okay, so by using 1 over 3. Okay, so multiply with 1 over 3. So we have this matrix. After that, make it this one become 0. And this one also become 0. So using the suitable formula, so we have this matrix. Okay, so after that, sudah kosong. Okay, so for the second row, make it this one become leading 1. So sini tak boleh lah leading 1. Sebab sini kosong, bawah pun dah kosong dah. Nak pindah row pun tak boleh dah. So cara yang lain, just ambil ni untuk jadikan leading 1. So by multiplying row 2 with 1 over 2. Okay, so therefore we have V1. Okay, so before that, so this one V1, V2 and V3. Okay, so for this one leading 1 for V1, this one leading 1 for V3. Okay, so V2 is free variable. Okay, so from first row, so we have V1 equal to 0, and from the second row we have 1 V3 equal to 0. Okay, so for the free variable, so we let V2 equal to R. Okay, so therefore we have the eigenvector V, which is equal to 0, R, 0, where R element in real number and R cannot equal to 0. Or you can write down in this form. So R 0, 1, 0, R element in real number and R cannot equal to 0. Okay, so from here, you can see that only one vector that we can use to become the basis of the eigenspace. Okay, so basis dia ada satu sahaja. So since the geometric multiplicity is equal to 1, which is not equal to algebraic multiplicity for lambda equal to negative 1, which is 2. Okay, so dia untuk lambda negative 1 tadi, algebraic multiplicity dia ada 2. Tapi geometric multiplicity dia 1. So therefore A is not diagonalizable. Okay, so kenapa? Sebabnya untuk form matrix P, dia 3 by 3 kan. So this matrix P also must be 3 by 3. But for the matrix P, so we form it using the eigenvector. Okay, so kat sini kita ada 1, 0, 1, 0. Okay, so yang lain lagi 1, dia akan muncul untuk second lambda. So untuk lambda yang kedua ni, so lambda sama dengan 2. Okay, so untuk lambda sama dengan 1, dia dapat 0, 1, 0. So untuk lambda equal to 2, so we have here V1, V2 and V3. So dia dah tak jadi 3 by 3 lah. So dia kiranya matrix P dia ni tak wujud lah. So that's why A is not diagonalizable. Okay, so tapi nanti ada cerita lain lah. Kalau korang belajar lagi tinggi, adalah benda yang lain nanti. Okay, so abaikan yang tu. So korang just tengok ni geometric multiplicity. Kalau tak sama dengan algebraic multiplicity, so A is not diagonalizable. Okay, so next, so ni conclusion dia lah. So how to determine if matrix A is diagonalizable? So dia ada dua cara lah. Yang pertama dan yang kedua. So panjang-panjang tadi cuma ni je lah dia punya conclusion dia. Okay, so this matrix A is diagonalizable if and only if matrix A has n distinct eigenvalues. Yang tadi lah, dia ada eigenvalues yang berbeza. And then second, for every eigenvalue lambda. Okay, so kalau kita tak jumpa yang n distinct eigenvalues, katakan dapat yang berulang, so kita pergi ke cara yang kedua. So cara yang kedua, for every eigenvalue lambda of A, the algebraic multiplicity of lambda is equal to the geometric multiplicity of lambda. Okay, so example here. Okay, so this example I take it from previously, which is star example. Okay, so star example. So dalam yang ni saya dah ambil daripada sana sini. So dah ada eigenvalues dan eigenvector dia. Okay. Okay, so this one. Okay, so biasa soalan exam macam ni lah. Dia akan combinekan eigenvalues, eigenvector semua sekali dengan diagonalizable. Okay, so question A. Find the eigenvalues of A and determine whether the matrix is invertible or not. Okay, so macam mana nak check matrix A ni invertible or not? Okay, so nak check dia, kita boleh check daripada eigenvalues. Kalau dia ada kosong dalam eigenvalues dia, so katakan lambda ada eigenvalues yang kosong, so A ni not invertible. Okay, so from start example, the eigenvalues for A is lambda equal to 1, 1, 3. Okay, so since there is no zero eigenvalues, there is no zero in eigenvalues, so A is invertible. Okay, so kalau tak ada kosong, dia maksud dia invertible. Okay, so B, find all the eigenvectors of A and basis for eigenspace. Okay, so from start example, the eigenvector for lambda equal to 1 is this one. Okay, so ni lah eigenvector dia. Okay, so therefore the basis for eigenspace for lambda equal to 1 is 1, 0, 0 and 0, negative 1, 1. Okay. 1, 0, 0 and 0, negative 1 and 1. Okay, so for lambda equal to 3, so dah cari dah daripada start example. So we have this eigenvector. Okay, so the basis, therefore the basis for eigenspace of lambda equal to 3 is 1, 0, 1. Then C. So C, soalan dia, is A diagonalizable and give a reason for your answer. Okay, so A diagonalizable or not. Okay, so untuk check diagonalizable, so first tengok lambda dia. So dia tidak berbeza, ada dua lambda yang sama. So therefore kita kena check dia punya eigenvector. Okay, so kita kena check algebraic multiplicity and geometric multiplicity. So for lambda equal to 1, so algebraic multiplicity equal to 2 and geometric multiplicity also equal to 2. Okay, so lambda sama dengan 1 tadi, dia berulang sebanyak 2 kali. Dan geometric multiplicity tadi, bilangan basis dia, so dia ada 2, so which is equal to 2, sama. So for lambda equal to 3, so dia berulang sebanyak sekali, so algebraic multiplicity is 1. Then for the geometric multiplicity, so number of bases which is 1, so 1. So hence A is diagonalizable because all algebraic multiplicity is equal to geometric multiplicity. Okay. Then D. So D, find the matrix P and D such that P inverse AP equal to D, where D is a diagonal matrix. Okay, so matrix P tadi, okay, so saya tulis sini lah. So matrix P terhasil daripada eigenvector. So kita ambil yang ni. So 1 0 0. So 1 0 0 and 0 negative 1. Negative 1 1. And another one which is 1 0 1. So 1 0 1. Okay, so for the matrix D, it is equal to, okay, so the eigenvalues, all the eigenvalues in the diagonal. Okay, so untuk yang pertama, kedua ni kita ambil daripada lambda equal to 1. So therefore for the lambda equal to 1, we put on the first column and second column. Okay, and then for the third column, we have 0 0 last lambda which is 3. Okay, so dah siap. Okay, so that's all for our lesson today. See you later. Thank you and Assalamualaikum.